So let's do some factoring review. We notice we've got a negative in front of this 2x squared, so I need to factor that out because this graph is pointing down. So when I factor out a negative, I'm left with 2x squared plus x minus 6 equals 0. Use the x box in this one? Yeah? You want to do it the other way? How about we do rainbows and checks with this one and x box with that one? Okay. So I want to do x box or a box x. Do you guys remember why I said you should do the box and then the x?
Yep.
Oh, I did. Thank you. I just said I was going to do it the other way around. Okay. Rainbows and checks. Let's do the 2 first. That one's easy, right? It's got to be 2x and x. Now 6 could be 1 and 6 or 2 and 3. So which one you want to try out? You think it has to be 2 and 3? All right. So the 2 here or the 2 here? 2 here? Here? 2 and 3? So that's 2x and 6x. Is that going to get me what I need? Nope. So we should do it 3 and 2?
Yep.
3 and 2. This is 3x. This is 4x. If I made one of these negative, I would have 1x. So which one's got to be negative?
3.
Right? Because this would make it negative 3x. Do you see how I did that? Now it's negative 3x and positive 4x makes x. And that's what we needed right there. Okay, so we're not done solving yet, right? What do I need to do with this? Make it equal to 0. Each one equal to 0, right? So I've got 2 separate equations. I've got 2x minus 3 equals 0, and I have, forgot my addition sign, x plus 2 equals 0. When I solve for this one, I get 2x equals 3, so x equals 3/2, and over here I just get x equals negative 2. What did I find? The x-intercepts, or the zeros. Perfect. Okay, what about this one? This one's an easy one. We can do rainbows and checks with this one pretty easily, right? Correct? Whenever the coefficient is 1, this is the easier way to go, right here. So x is broken up as, x squared is broken up as x and x. What do I have to break 81 up to get a negative 18? Negative 9 and negative 9. Does it work? Negative 9x and negative 9x make a total of negative 18x. Looks good to me. This is what I needed right there. So this is actually called a perfect square trinomial. So I don't need to solve both of them for 0 because they're the same, right? What does this graph look like? First of all, if we solve for x minus 9 equals 0, what's that? X equals 9. So what would that look like on a graph? What did I just find? An x-intercept. If there's only one x-intercept, what's that graph look like? Not a line. This is the intercept. So if the intercept's over here at 9, what does that graph look like? It's a parabola because there's an x squared. It's positive, so it's up. But there's only one solution. There's only one x-intercept. Just skimming the graph right there. Touches right there. okay? When you only have one X-intercept, that's all you can do, right? It comes down and it touches it right at 9 and it goes back up. So that would be our vertex, right? About this one. Anybody see anything interesting about this one?
GCF.
A GCF first. That's always our first step, is a GCF, correct? What can I pull out of everybody? A 2, which gives me 3x squared minus 7x minus 6 equals 0. Do the x box on this one? Yes? Or is everybody agreeing that you want to do this rainbows and checks? Keep with the rainbows and checks? Okay, you guys are liking that better? Okay, I've got to keep my 2 out here. It doesn't just go away. It does, however, do nothing for my graph when I'm talking zeros, and I'll explain that in just one second. All right, so this is probably the easier one. My first, right, are 3x and x. What are my last? What do you think? You want to try 6 and 1? If I put 6 here and 1 here, I'm going to have a 6 and a 3. That's not going to help me. If I do a 1 and a 6, I'm going to get 1 and 18. That's not going to help me. 2 and 3? 2 and 3. 4, that's going to be 2x and 6x. Is that going to help me? What about 3 and 2? 3 and 2. So I'll have a 3x and a 6x. That doesn't help me. Where do we mess up? We had 1 and 6. Did I mess it up? 1 and 18. That doesn't work. 6 and 1. 6x, 3x. That doesn't work, right? Two and 3. 2x. Oh, right here. 2 and 9. That's where I messed up. Since this is negative, one of these has to be negative, right? So if this is negative and this is positive, I would have 2x and negative 9x, which makes negative 7x. So guess and check, right? All right, so we have 2 times 3x plus 2 times x minus 3 equals 0. We can't set 2 equal to 0 because 2 does not equal 0. So 2 doesn't affect us. 2 has nothing to do with the x-intercept. 2 has something to do with, when it gets multiplied back in, has something to do with the slope, but it's not doing anything with x-intercept. Now, if there was an x next to it, then it would have something to do. Because if I put 2x next to a 0, what's x? X is 0. 2 times what makes 0? 0. Right? Divide by 2, divide by 2, x equals 0. But that's not what we have. You still need the 2 out there in your answer because it's factored out. You don't want to forget about it because it's still part of the equation. But when you're trying to find the x-intercepts, it doesn't help you out any at all. Does that make sense? Okay. So I'm going to set 3x plus 2 equal to 0 and x minus 3 equal to 0. When I solve for this, I get, let's skip some steps, 3x equals negative 2, therefore x equals negative 2/3, and this one's just x equals 3. Questions so far? All right. If you need more help with this, we can do it all day long if you want. Okay, I can show you how the X box and the rainbows and checks are directly related. Okay? All right, identifying squares. So, did these change? All right, I saved it and must have put it on the drive and not on my computer, so I'm just going to make my own. Okay, check this out. What if we did 36x squared minus 49y squared equals 0? What do you see there? I see squares. Right? Specifically, if all of these are squares and there's a minus sign right there, this is a very special situation. We have a special name for it. Subtraction means difference. Nobody? Yes. But I know what you're talking about. It looks like it, right? Because of the squares and the minuses. Good job. I like that. You remember that from last year, right? Good. We're getting our second semester, guys. This is the difference of two squares. Remember that phrase? The difference of two squares? Right, so 36x squared minus 49 squared. This is a square. This is a square. This is a square. And this is a square. The difference of two squares has a plus and a minus. You take the squares out, and there's a square in front here, and these squares go here. Difference of two squares. You guys used to see it like this, which would be x plus 5, x minus 5. This is the same exact thing, there's just more squares in there. Perfect square trinomial would be, give me a square, that's a number.
4.
4, okay, 4x squared, give me a square, another one. 9y squared. A perfect square trinomial will have this square and this square in the middle, but a 2 multiplied by it. So what would be this middle term? So if the square here is 3 squared, and this one is 2 squared, then 2 times 3 is 6, and what's 6 times 2?
12.
Check this out. Watch what happens when I factor it. So this would be a 2x, and this would be a 2x, and what do you think this is going to be? A 3y and a 3y. Rainbows and checks. Does that make 6xy and 2xy and 6xy, which makes 12xy? So there's a pattern here. You don't always have to see it, but when you see squares, you should be looking for squares. When you see squares, you should say to yourself, is it the difference of two squares, or is it a perfect square trinomial? Let me show you one with a negative sign. Give me another square. 16x squared. Give me another square. 25y squared. What's the square in there?
4.
What's the square in there? 5 times 4 is? 20 times 2 is?
40.
I'm going to change it up a little bit. Make this a minus sign. How do you think that's going to affect this? Not at all?
4. Oh.
I made this minus sign, so check this out. So what's going to be my first? 4x and 4x, and what's going to be my last? 5y and 5y, and instead of plus signs here, they're both going to be negative signs, because 20xy and 20 xy are both negative, which adds up to 40xy. So normally teachers will show you to factor it and then see the relationship. I'm trying to make you create something that is a perfect square, so you'll always see the relationship. Let's make another one. Make another one for me. Let's do easy, 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 easy. 4. 4x squared. Don't give me a y, just 16. What would be the middle term to make this a perfect square trinomial? This is 4. This is 2. 8 times 2 is 16. Does it work? Let's see. What would this be? 2x and 2x, and what would this be?
4.
8x and 8x make 16x. All right, let me give you one. 3x squared plus 9 plus 6x. Is that perfect square trinomial?
No.
It can't be. Why can it not be without doing any work? Because of the 3. That's not a square. What about this one?
Yes.
X plus 3, because 3 times 2 is 6. Right? You see how I'm doing that in my head? Okay. So, like I said again, it's not necessary to recognize perfect square trinomials, but wouldn't it make your life a lot easier if you could recognize them and not have to factor stuff out? It'd be nice to look at that and go, oh, that's a perfect square trinomial. I see a square there and a square there. If I square root both of them, multiply it by 2, I get that. Yep, there's my perfect square trinomial. Perfect square trinomials are always written like this. This one, however, is necessary. Difference of 2 squares is crucial. I think coming back from I took 8th grade Algebra 1 as well. Coming out of my 8th grade Algebra 1, that's the one thing I remembered the most, was the difference of 2 squares. Why? Because it made my life so much easier. I loved it. Oh, that's difference of 2 squares. I don't have to do any work on that one. I don't have to do the guess and check at all. I already know that one. So that's why when we did our lesson yesterday, what was my first step? You guys remember what the first step was? Oh, first one was GCF. What was the second step? Look for squares. Look for squares. They'll make your life easier. Okay, we'll do factoring every day, like I said, for 2 days. No need to get out any type of paper or notes. I've got notes for you. I just want you to watch. I mean, you're going to actually, this is actually your first homework problem. And I have a worksheet for you. So you don't have to do this on anything. Alright, so the first thing, my first step is to factor and solve. So I'm going to go ahead and factor and solve. What should I pull out before I factor this at all? A negative. This is an upside down graph. That's what this looks like. I can tell right there because of the negative. So I'm going to pull the negative out first. We'll call this A. This is my first step. I'm going to pull a negative out, and I have x squared minus 4x plus 3. Go ahead and factor that. Easy one to factor, right? X and x. What am I going to break 3 up? There's only one way to break it up, right? 3 and 1. Which one's going to be positive? Which one's going to be negative? Or both have to be negative. They both have to be negative because negative 3 times negative 1 is positive 3. This is the only time when both have to be negative. When this is negative and this is positive, because I have 2 negatives making a positive. Okay? All right. So, if I set this equal to 0, I have x minus 3 equals 0, and I have x minus 1 equals 0. I don't need these parentheses. So x equals 3 and x equals 1. What did I just find? 3, and 1. All right. My next step is to find the axis of symmetry in vertex. I know my axis of symmetry is where? Can you see it? I see it. If we have symmetry, right, doesn't it have to be at 2? I'm going to show you how to solve it. The equation for an axis of symmetry is negative b over 2a. I sure can. So negative b over 2a. Let's identify our a, b, and c. Here's a. We have to go back to the original, right? Here's b. Here's c. So negative b would be negative 4 over 2 times negative 1, which is negative 4 over negative 2, which is positive 2. So that's my axis symmetry right there. We could already see it before we found it. Now, I need to find my vertex. And this, I forgot something. X equals negative b over 2a. Why? Because we go over to 2 on the x. I'm solving for x right now. All right. So in order to find my vertex, I know it's going to look like this, right? So I know it can't be down here. It's got to be up here. That's what helps me with my behavior of graphs. All right, if I know what x is. If I go over to 2, that's my x on my when I'm trying to find my vertex. Now I just need to find my y. So I'm going to take my original equation, plug in x, and that'll give me y. So if x is 2, f of 2 would be negative 2 squared plus 4 times 2 minus 3. 2 squared is 4, so this becomes negative 4. Scooting it up again. Plus 8 minus 3. Negative 4 and positive 8 is positive 4. Minus 3 is 1. What I just find? The vertex. When x is 2, y is 1. So I'm going to go back up and plot that. When x is 2, y is 1. Does that make sense? Oh, am I not quite there? There it is. Thank you. See how that is measuring in halves? So there's my graph right there. I didn't make it. Alright, so it said C was find the y-intercept, so that's what we did right here. Oh, I haven't found the y-intercept yet. See, how do I find the y-intercept? How do I find the y-intercept when I do it with a regular graph? If I want to find the y-intercept, what do I do with x? Do you remember? What? Substitute it in. Just a regular line graph. Remember it was on the quiz? What?
Oh,
make it 0. If you make x 0, you'll find y. If you make y 0, you'll find x with a regular graph, right? So if I make x 0, wouldn't that just cover, when x is 0 here, doesn't that just cover it up? When x is 0 here, doesn't that just cover it up? So when x is 0, what's y? Do you guys see a correlation with a regular y equals mx plus b? What is b always? The y-intercept. It's also the constant, right? It's the only one that doesn't have an x. This is the only one that doesn't have an x. So when you see a graph like this, that's always your y-intercept. So where's my y-intercept? Negative 3. Does that make sense with my graph? Shooting down? Yeah? If that's here, and that's 2 away, don't I have symmetry here as well? Alright, so we put in 0, and we got 0 plus 0 equals minus 3. Is that right? All right. D says use A through C to graph the quadratic function. I already graphed it as I was going, which is what I suggest you do, because if you do all this without actually doing the graph, I mean, I could see what was happening as I was doing it, right? I was seeing the behavior of it. E is this a minimum or a maximum graph? I think of it like Mario jumping. Is that the maximum height or the minimum height he's going to be able to jump? Right? Jumping up like this is max. Going like this is min. The minimum level you're going to be at. The maximum height. All right, so that's a maximum. And finally, I have a domain and range. Domain. What's my domain? If I'm going along X. Ask yourself this, is there any point that isn't involved? If this goes like this, is there ever going to be a point where it's not involved with X? Yeah, well, not infinite, it would be all real numbers, right? Okay, I think that's a better way to describe it, right? Not what X is, but what X isn't. Is X not anything? No, it's always going to be something. What about Y? Is there any place where Y isn't?
No.
No? If you're on the Y-axis right here,
Oh, yeah.
see it? Everything above that line right there is never going to, the graph will never interact with anything up there, right? It'll always be pointed down. Is it ever going to go up there?
That's fine.
So Y is less than or equal to 2 would be my range values. All right, I'm going to hand out your homework, and I'm going to let you copy all of this down. Have that with me, please. Okay, I'm going to move you guys right now. I'm not happy right now. Every time I look over there, you guys are chatting or making some comment to each other. I don't tolerate disrespect very well because I think I'm really, really cool with students. So I get my feelings hurt very, very easily. Sorry, that's my downfall. Gary, can I exchange you and Grant? Will you be okay there?
Oh, yeah.
Yeah? All right, Grant. So you guys do number 1, and then I'm going to do, the next one I'm going to do is I'm going to do 5 next if you want to get started on number 5. Thank you. just let me know when you need to move it up. You see how much homework I gave you today? I want these to be solid, right? I want to be able to do these and have you guys successful at these. We're going to do the same thing tomorrow too, just a little bit harder. So it's going to be the same concept, okay? Hey Alex, will you pass back the homework now, or did you guys already get it back? Awesome. Thank you. Which is, why are we solving quadratics? Why are we solving quadratics? Why do we factor a quadratic? Find the X-intercepts. You want me to give you today's? Today's closing thought. Here's today's closing thought. Then we'll go through and we'll do another example. Today's closing thought is, I noticed in a quadratic equation the constant is always what? What's the constant always? The y-intercept. Good job. The constant is always the y-intercept. That's all you need to write. The constant is always the y-intercept. If you want to write something down and circle 6 like I did, do it. I just want you to remember it. Can I go back? Okay, I'm going to go down for you. Then we'll do another one. B. B was 4. It's negative B over 2A. A, B, C. You're welcome. So there's 3 of these on your quiz next Wednesday or Tuesday. They're not. It's not getting any easier, guys. This is the beginning of Algebra 2. How many of you have had Algebra 2 yet? Already. A few of you? Okay, so this is the beginning of the hard stuff. It gets much harder. You guys ready for me to go on? If you're done, you should be starting the next one. I said I was going to do number 5 next. Danielle, I have paper for you. Danielle, you also missed a quiz that you're going to have to, or a quest that you're going to have to make up. There you go. If you download my notes, 3 of your homework problems will be on there, okay? So don't worry that we didn't get through all of it, all right? So you'll be able to do 2 of them and be able to look and see if you're doing it right, okay, if you look online. And I'll make sure I post it before I go to my meeting tonight. All right, you guys ready? The next one? All right, so my first step is to factor and solve. This factoring problem is a little bit easier. Hold on. After step 4.
So after 6 or 2.
Yeah.
I have a question about last night. Okay, I did the X method, but there are different answers in the end.
Okay, sounds good. Thank you. Bye. Here's my best example. I started graphing quadratic equations to algebra 2. I went over a review of perfect square trinomials and the difference of two squares. I said difference of two squares. They looked at me like they had never heard that term ever before in their life. And that's crazy. That's very scary. Anyways, I just want to show that. That's crazy. They looked at me like they'd never heard those words ever before in their life. They had to have seen it. But no, they're like, we haven't seen that since 8th grade. I'm like, yeah, but when I had it in 8th grade, it was ingrained. Those words will never leave my mind. You know what I mean? Scary. Okay, all right. Today what? Today.
No. Let's just get it over with.
There's a reason why.
Proceeding to test today, right?
Yes.